Okay, so let's take a look at the ambiguous case. So I'm given a triangle. The measure here is 15, 28, and I've got an angle 110. So I have side, side, angle, okay? We know that the law of sines applies. Sine A over A equals sine B over B. So what we'll have here is we'll have sine of 110 degrees divided by 28 equals sine of some measure B divided by 15. So let me grab my calculator here. Calculate this out. So I have here, if I wanted to find sine of B will equal to multiply by 15 sine of 110 divided by 28. Obviously this isn't drawn to scale. 110 is more than the acute angle that I have drawn there. So I have 110 sine of that times 15, good, divided by 28. So I have sine of B here equals, I have 0.503. Now, we know that there are two angles, okay, B, that satisfies sine of B is equal to 0.503. Here's the deal. If this number is less than 1, there's always going to be two numbers that can be put in for B that will equal it. A number and its supplement, okay? If you think about that unit circle, right? A supplement meaning 180 minus it, right? When do I have a height on my unit circle less than 1, right? Well, all these values, but if I get this one, don't I also get this one here? Okay? So because of that, we're going to have two. So if I do sine inverse of 0.503, that will equal my B value. So if I do sine inverse of that thing, I get to here approximately 30.22. Okay, but I also have 180 minus 30.22, which is equal to 149.77. Okay, so here's the deal though. Is this possible degrees? So this is one, and this is the other degree. Is this possible? This one's possible. Why is this one possible? Because if I put 30 degrees and change in here for B, okay, 30.22 degrees, this is all going to be under 180. This plus this plus this is going to be under 180. But the problem with this one is, what happens if I put 149.77 in here for B? Well, 149.77 plus 110, I'm already over 180. The sum of the interior angles of a triangle must add up to 180. So this case doesn't work in this situation. So in this case, my only solution here is this value. So I have 30.22 for this guy. How do I find the measure of C then? Go through my same deal. You could use the law of sines again. So I have sine A over A equals sine C over C. Do we know what the measure of C is? Sure. What do we do? 110 plus 30.22, 140.22, 180 minus that, 140.22 gives me 39.78. So it'll be 39.78 degrees. So I'll have sine of A, sine of 110 divided by 28 equals sine of 39.78 divided by C. So I'll have here C, multiply it over, equals 28 times sine of 39.78 divided by sine of 110. Okay, let's see what I get here on my little calculator. So 39.78 sine of that guy times that by 28 divided by 110 sine, and I get 19 approximately. Approximately 19. That's about 19. Okay. So again, this case didn't work. Why? Because the sum of the interior angles was over 180. So I only had one case in this situation. Okay, so now I have another triangle. Suppose I have side-side angle again. Okay, I got 186.2, 248.6, and 43.1. I want to use the law of sines to figure this out. Well, what I can do is I can figure out the measure of this angle B right here, because I have sine of 43.1 divided by 186.1 equals sine of B divided by 248.6. So therefore, I can figure out that sine of B, let me get my calculator here, and I get 43.1, oops, 43.1 sine of that guy, good, and divide that by 186.1, good, times it by 248.6, and I got 0.9122, like 5-ish, okay, good. So that's what I get. Now here's the deal. This number is under 1, right? So I know I'll have two angles B, such that sine of B equals that number. So if I take the inverse sine inverse of 0.91225, okay, so I do sine inverse of 0.91225, I'm going to get 65.8, okay, so I get 65.8. So, would that be okay? 65.8 would be fine. 65.8 degrees, no problem. However, what's the supplement to 65.8? 180 minus 65.8 is equal to 100 and what? Oops. 114.2, is that right? 114.2? Yeah, looks good. Okay. So it's 114.2. This number plus this number is not over 180, is it? Again, this would have been bad if it had been like 150, because then I'd have 150 plus this is too much, 190 something. But since it's 114, okay, that can also mean that that's a possible value for the angle measure of B. So what I have is I have a new, make this a little smaller, 43.1 degrees. I have a new possible measure of B, right? And this, where this distance is still 186.2, but this angle is 114.2 degrees, okay? 114.2 degrees. So now I have two possible values. Call this B1, call this B2, and what you have to do then is solve both of these triangles and get both of the measures of all the sides. Okay, so this is a two-part problem, right? You got to do one triangle, figure out that, because there's two triangles that could solve it, and also the other. So we know that we have one of two angles to be this B value, so we need to find the other parts of the triangle that correspond to it. Well, if I have 43.1 and let's say 65.8, so I'm going to do the two triangles separately. Here's one triangle right here. This is B1, C, and A, 43.1, 65.8, and 248.6 and 186.2. Well, if I have that, that forces the fact that this has got to be 71.1 degrees, so this is 71.1 degrees because these two have to add up to 180. Therefore, how do I find the measure here of this value C, little c? I go sine of 71.1 divided by C equals, say, it doesn't matter which one you choose. I'll do sine of 65.8 over 248.6. And I think if you do this math, I think this C value becomes to be 257.6. 257.8, excuse me. 0.8. Very good. So that's one triangle, but then I also have to do the other triangle. So if I do the other triangle, where I have B2 there, it looks like this, right? B2, C, A, 43.1 degrees, 114.2 degrees, 248.6 as a measure, and 186.2. Okay, now we can tell that this one is 114.2 plus 43.1. Okay, 180 minus that will equal its value. Turns out this number right here turns out to be 22.7 degrees, and so this turns out to be 22.7 degrees. So then I can use my same formula. Okay, sine of 22.7 is to some value down here. Okay, C as sine of 114.2 is to 248.6. And I think if you solve this thing, I think you get C equals 105.2. Okay, so this is the ambiguous case. There's two possible values, and there we go.